Hello there, welcome to the series of video lectures on engineering mechanics. In continuation of that, one more problem we are going to be doing on the kinetics of particles. In this case, the force are going to be the cause for that motion, and the field parameter also we are going to be calculating. To understand for the better, so please follow the series of video lectures so that your understanding capabilities are going to be increased a little better, right? So getting into the problem here, the two blocks weighing 50 newtons and 25 newtons. The 50 newtons and 25 newtons are connected. So in this case, I am going to say W1 is equal to, I am going to say this is going to be the block 1 and this is the block 2. W1 is equal to 50 newtons, sorry, this is the 50 newtons. And W2 is going to 25 newtons. Connected at the two ends of light inextensible string, right? Block 1 and the block 2, they are connected one inextensible string, and they used the pulley also over here to reduce the friction or for the easy lifting. Passing over a smooth pulley, that means we are not going to be considering the friction between the rope as well as the pulley. The block weighing of 50 Newton is placed on a smooth horizontal surface, while the block weighing 25 Newton is hanging free in air. So it means that mu1 I am going to be taking is equal to 0, because this is going to be a smooth surface, it is going to be on the horizontal. That means the friction between the body as well as the horizontal plane. And what you want to calculate, you need to find out the acceleration of 1, acceleration of 2 we need to be calculate, and the tension in the string also that we need to be calculated. So how we are going to do? Initially we are going to be taking the free body diagram. So now we are going to be draw the free body diagram for the 50 newtons, that is the block 1. So here I am going to be taking, here is the block 1 and here that's going to be acting. So the self weight always I am going to be taking in the downward direction, that is the 50 newtons, right? And once I am going to be removing this horizontal surface, we are showing with the normal reaction, and 1 I am going to be shown, and here is the tension I will show in this direction T1, right? And what other forces we do have? Which direction we are going to be assuming the motion of this one? I am going to be assuming the body is going to try to move in the downward direction. It means that this 50 newtons is moving in the towards the right side. So then what are the frictional forces are coming into the picture, right? So F is going to be acting towards this side. Fi1 I am going to say that is acting towards this side. So we need to be find out other parameters here. In this case, N1 I am going to be calculating sigma Fy is equal to 0, N1 is equal to 50 newtons. But the frictional force is equal to, what is that one? Mu1 and 1. Mu1 is equal to 0, then finally we got it the 0. Fy is equal to, what is the formula? That's going to be M1, A1 we are going to be getting. So M1 is equal to, what is the final equations from this one? That I am going to be taking Fi1 is equal to W by Z into A1. W is equal to 50 by 9.81 into A1. So this simplification I will get it. The 55, 9.81 is equal to how much we are going to be getting here? That's going to be 5.09 A1 I will get it. Right? So these equations we got it. I am writing over here in terms of Fi1 is equal to 5.09 A1. Alright. So then I am going to be writing the total equations here. What is the total equation? What is the cause for that motion of this body? So that's going to be sigma f of x equal to 0. What is the sigma f of x is equal to 0? We need to find how many forces. 1, 2 are in this direction. This force is going to be acting in this direction, but this force automatically is going to be 0. That's the T1 is equal to Fi1 plus frictional force 1. This force is going to be the 0. The T1 is equal to 5.09 A1 I got it. Then I can say this is the equation 1. right? Once I'm going to be getting this, then I'm going to be taking the body to the free body diagram. I'll try to develop the same kind of the equations by using the sigma f of y is equal to 0, sigma f of x equal to 0. Now take the block 2. So this is going to be your free body diagram, and the self weight is going to be acting in the downward direction, that is the W1, and similarly the tension is going to be acting in this direction, because the tension here and here is going to be the same, because here is the friction is going to be the nil. So then this body is going to be trying to move in this direction. This is going to be your motion is in the downward direction. So then what other forces come into the picture? Because there is no physical contact here, the frictional force is not there. Air resistance force also we are not going to be considering. Then, but inertia force is going to be acting in the upward direction, that is the Fi. Right? So here W1 is equal to 25 newtons is there. Now I need to calculate the Fi2. So Fi2 is equal to, that's going to be M2 into, so that I am going to be getting the A2, that is the W2 by Z A2. Fi2 is equal to 25 by 9.81 A2. Fi2 is equal to, that is the inertial force of the block 2 is equal to 2.548 meter per second, sorry, into acceleration, A2 in the newtons, that I am writing here. Fi2 is equal to 2.548 A2, right? So once if I am going to be find out, then I am going to be taking the equilibrium equation or the D'Alembert principle, so that I can calculate it. So here that's going to be sigma f of y is equal to 0. That's going to be your the D'Alembert principle. So can you see T1 and the F12 is acting towards upward direction, W1 is going to be acting in the downward direction. That's going to be T1 plus Fi2 is equal to W1. So further simplification of these equations. So this is the T1. So T1 is equal to these equations. What I am going to be say? That's going to be plus 2.548 A2 is equal to 25 newtons. This is the another equation, we got it. This is the second equation. This is the first equation. Alright. So in this case what will happen? T1 is going to be the common. If I am going to be substituting in this equation, in the single equations we are going to be getting the two unknowns. So then I need to assume here one of the parameters that's going to be A1 is equal to A2. If so, then that is equal to the acceleration. It means that the block 1 and the block 2 have the same accelerations. So then if I am going to be substituting the equations over here, then finally I can get the value of that. So that means I am substituting 1 in 2. So substitution 1 in 2 equation. So the T1 is equal to 5.09 A plus 2.548 A, that is equal to 25. After the simplification of this equation, okay, so then A is equal to, what is the A here? From this equation I got it 3.27 meter per second square. Can you see? By assuming only this parameter, only we can do this part, because the tension is going to be the common. Only the other parameter is the A1 that we need to be calculated. A is equal to. So from these equations I am going to be writing A1 is equal to A2 is equal to 3.27 meters per second. So once if you are going to be calculating, so then we need to be calculate the tension in that part. So how we are going to be getting here tension? So that's going to be T1 is equal to, substitute in your equation 1, 5.09 into A1 is going to be 3.27. So if you are going to be simplifying this equation, I am going to be getting the 16.67 newtons. This is the tension is existed when the body is trying to move in the downward direction, because it is connected between the block 1 as well as the block 2. So here I am going to say the T1 is equal to 16.67 newtons. Here also the T1 is existed. So this way we are going to be solving. I hope you are able to understand here. What is the difficulty in this problem? The difficulty problem here is that we don't have the acceleration of these components. That's we need to be calculated. At the same time, tension also in the string we need to be calculated. So the final, if you want to get it, one parameter we need to be assumed is going to be, that is the your acceleration component we assume, that's the a1 as well as the a2 is equal to the same acceleration. On that basis we are able to solve it. I hope you people are able to understand the problem of the difficulty or the degree of the difficulty and how we are going to be making to solve it. Okay, if you have any doubts or any questions, please put in the comment section so that we are able to discuss that part. Thank you.